Hello, friends. Today I had the opportunity to be present at the GMERS Medical College at Dharpur near Patan. The audience was first year MBBS students, and the topic was AI and ML for the beginners. We talked at length about that with a lot of question and answers. The content as a recording is available with me, and there are two AI avatars who are discussing it as a podcast for you guys. Please go ahead and listen to it and enjoy the session that I had today. Thank you.
Welcome back to the deep dive. Today, we are focusing on really the engine room of modern technology. Our mission is to strip away some of the hype around artificial intelligence and machine learning, get down to the foundational how and why they work, especially in your world, the demanding field of clinical practice and medicine. We really have to cut through the noise straight away. Tools like ChatGPT or Grok, they're interfaces, essentially, wrappers.
That's right.
Think of them less like different toothpaste brands and maybe more like specialized surgical instruments. You've got a tray, a dozen tools. They all cut, right? But the specific material, the angle, the durability, that tells you if it's the right one for this specific procedure. So our goal is to understand that core mechanism so you know which instrument to pick up and when.
Exactly. The focus has to shift from just what the name on the box to the how, the engineering underneath. So imagine you're running a complex simulation in the OR. That simulation, it's only truly useful if you understand the physics, the rules governing it. If you don't really grasp the mechanics of how AI works, well, you can't fully trust its output, can you? And you certainly can't maximize its potential in a high-stakes clinical setting.
Okay, right. Let's unpack that a bit. A lot of people, I think, still talk about AI as if it's coming soon.
Yeah, you hear that.
But that ship has sailed, hasn't it? We are here. Even basic consumer reports show generative AI is part of the conversation for pretty much everyone now. But here's where the infrastructure behind it gets really startling, especially when we talk resources.
Precisely. When we talk about these large language models, these big AI systems, the vast majority, they rely on just a handful of massive core engines, often from companies like, OpenAI or Google.
Right.
And these engines need an infrastructure that's almost, unbelievable in scale. We're talking huge data centers using enormous resources, vast amounts of electricity, complex cooling systems, needing millions of gallons of water, and just petabytes upon petabytes of storage.
Wow, petabytes.
It brings up a really critical point about cost and value. While the cost for, say, a single query might seem tiny, fractions of a cent perhaps, the aggregated cost of training and just maintaining these huge models, that runs into the billions of dollars. So every single query you make, even on a service that says it's free, it's consuming a tiny slice of that massive shared resource pool. And that cost is often subsidized because your usage, your questions, your clinical focus, how you interact, that's being collected. It's used for machine learning. Your data effectively is the currency here.
Okay, that data collection point is key. It brings us straight to this idea of persona. The machine isn't just passively answering, is it? It's actively defining you as a user.
It's building a model of you.
Right. It works out a usage pattern, a kind of machine persona based on the questions you ask, the specific way you frame your clinical inquiries. We see the simple version of this with online shopping, sure, but in a medical context, it must be far more specific, far more targeted.
Absolutely. That machine persona starts analyzing your clinical style. What kinds of differential diagnoses do you lean towards? The nuances of patient history you always check. Which drug interactions you flag consistently?
So it's learning my habits?
Exactly. This constant, complex pattern matching. That's the real engine of artificial intelligence.
Okay, so maybe we should just quickly lock down those basic definitions then, just to be clear.
Good idea. So artificial intelligence, AI, that's the big umbrella term, mimicking human intelligence with machines, broadly.
Got it.
Machine learning, ML, is a subset of AI. That's where the machine learns patterns directly from data without needing explicit programming for every single possible scenario.
Okay, learning from data.
And an algorithm. That's simply the core recipe. A defined step-by-step process the machine uses to do a specific task, like identify a pattern or make a prediction.
Right, the recipe, that distinction between the recipe and the actual intelligence, it leads us nicely to comparing, well, human intelligence versus these machine tools. Like, compare a really experienced tenured professor teaching biochemistry versus asking a tool like ChatGPT to just define biochemistry.
And the crucial difference there is experience and filtering.
Yeah.
That human teacher, they know from years of seeing students struggle and succeed exactly which concepts are vital at a certain level. They know the common pitfalls, the necessary context.
They tailor it.
They tailor it, precisely. They provide relevance. The tool, on the other hand, well, it can be incredibly thorough, but it just gives you everything you ask for, often without that necessary filter or context or, frankly, judgment. And we connect that to the bigger picture. Human thinking works on knowledge, yes, but knowledge synthesized through experience, through application. The depth of human thought comes from the depth of that integrated knowledge and all the contextual layers built up over time.
So it's not just about having the information. If the machine has all the data points, what's the ultimate nuance it lacks? Is it clinical judgment, ethical complexity?
It's all of that.
Yeah.
It's the ability to synthesize information beyond just black and white, 0 and 1. The machine operates on data correlations. The human operates, or should operate, on context, responsibility, and, yes, judgment.
Which is probably why the sources we looked at really emphasize viewing AI not as some kind of competitor, but strictly as a co-pilot.
Yes, that term came up repeatedly.
It's a collaborative tool, something you have to train, almost like domesticating an assistant based on your specific requirements. And especially in medicine, that training has to be highly specific to the clinical domain, right? Not just general knowledge.
Absolutely essential. That focus on specific domain-relevant training is critical. Because when we look at the applications mentioned in the sources, things like radiology, pathology, oncology, and even ethics, the ease of actually implementing AI varies wildly.
Yeah.
And it often comes down to the data.
Okay, let's start with radiology then. Our sources seem pretty clear that this is, relatively speaking, an easier win for AI compared to some others. Why? What makes the barrier lower there?
It's almost entirely about the structure and the sheer volume of the data. Radiology generates huge amounts of documented, structured data. Think MRIs, X-rays, CT scans.
Digital images, mostly.
Exactly. And crucially, these images often come with definitive labeled reports. Fracture present or nodule benign. That consistency, that labeled data set, allows the machine to recognize and compare visual patterns much more easily, more rapidly and effectively.
That makes a lot of sense. But, okay, if it's that much easier for radiology, why aren't we seeing the same really rapid uptake in, say, pathology or oncology?
Because the data there is often far less standardized, far more complex. Pathology, for instance, frequently involves quite subjective interpretations of tissue samples.
Right, looking through a microscope.
Yeah. And labeling what constitutes a specific pattern can be really nuanced, very dependent on the individual pathologist's experience and judgment. Oncology data, that's often fragmented across different hospitals, different systems using different protocols.
And real patchwork.
It is. So the lack of clean, unified, universally labeled data sets in those fields makes the training process much, much slower and more difficult.
So it always comes back to the data.
It really does, which raises the critical question. If data structure and labeling are everything, then we have to obsess over data quality. You absolutely have to stick to the principle of garbage in, garbage out, GI go.
GI go, heard that one before.
If you feed the system messy data, unlabeled data, or worse, biased data, the clinical predictions or insights you get back, they will absolutely be flawed, potentially dangerously flawed.
And that GI go problem, that's where the training comes in, isn't it? The source material talked about supervised training. Can you break that down simply for people dealing with these huge data sets?
Sure. Supervised training basically means you use massive amounts of labeled data. So imagine feeding the system, say, 1 million chest X-rays. Each one has been definitively tagged by expert radiologists as malignant or benign.
Okay, so humans label it first.
Correct. The system then makes its own prediction for an image. You compare the system's prediction to the human-provided label, the difference between the two. That's used as an error signal. It feeds back into the system.
Ah, a feedback loop.
Exactly. A feedback loop that corrects and refines the algorithm's internal understanding until it gets really good at accurately identifying the patterns associated with malignant or benign, in this example.
Okay. And if that initial labeled data, the human labeled stuff, is inaccurate or maybe reflects existing human biases, I guess that's where AI bias creeps in.
Precisely. That's a huge risk. If the training data is flawed, the AI learns the flaws, leading to potentially wrong decisions, disparities in care. It's a serious issue. And the sheer volume of data needed for this accurate, unbiased training is just staggering. We're often talking petabytes.
Petabytes. Mm-hmm. Which, just for context, is thousands of terabytes. It's almost unimaginable.
It's a colossal amount of information. And that volume immediately brings us to ethics. Why is ethics such a core part of this whole discussion in medicine?
Right. It was listed alongside the clinical field.
Because it ties directly to the confidentiality and privacy of those petabytes of patient data. Your sensitive patient information is often stored in the cloud, maybe managed by third-party AI developers. Whoever controls that data, well, they have immense power. They can manage it, manipulate it, potentially link it in ways you never intended.
That's worrying.
It means the ethical responsibility really falls heavily on you, the medical user.
Yeah.
You have to ensure you're only feeding accurate, anonymized where necessary data. You must protect patient privacy rigorously, because inaccurate data or misused data, that translates directly to potential patient harm.
Okay, that's a heavy responsibility. Let's shift gears slightly. The sources also talked about disruption. They framed it not just as a disturbance, but more like a necessary forward movement, something required by the times. The obvious recent example given was the COVID-19 pandemic, right? It forced the entire medical profession to learn new things, adopt new tech incredibly fast under immense pressure.
A brutal but effective catalyst for change in some ways. And when that kind of disruption hits, whether it's a pandemic or a technological leap like AI, you absolutely must be ready to learn, unlearn, and relearn. Constantly.
Learn, unlearn, relearn. I like that.
AI is a powerful tool for prediction, no doubt, but its predictive power is only ever as good as the data it was trained on. It lacks that fundamental human capacity for nuanced, contextual decision-making when the data is incomplete or ambiguous or the case is just unique, outside the patterns it knows.
And sticking with tools for a moment, there's so many options now. The sources mentioned a few: Copilot, Notebook LM, Gemini, Perplexity. You said earlier many use the same core engine. So how do we actually differentiate them? How do we choose?
That's a great question. You need to look beyond the core engine and evaluate their specific features, and crucially, how they handle your data. For instance, Perplexity is often highlighted because it really emphasizes citation and validation.
Ah, it shows its work.
Exactly. It tells you where the information came from. That makes it incredibly valuable for research, for verifying claims.
Yeah.
On the other hand, something like Notebook LM is specifically designed for analyzing and synthesizing your own private source documents.
So stuff I upload myself.
Right, which is critical if you're dealing with sensitive institutional data or patient notes that absolutely cannot be uploaded to a general public AI engine. So the best tool, it really depends on your specific data security needs and your clinical workflow.
Which loops us back perfectly to validation. We're swimming in information now, right? A lot of it machine-generated, some of it maybe even deep fakes. You just can't blindly trust what the machine spits out.
Absolutely not. You have to bring your own wisdom to the table. Your established medical knowledge, your clinical training, your critical thinking. Use all of that to verify every source, every AI output. You still have to decide which source is reliable, which suggestion makes clinical sense. You apply that human judgment that operates outside the simple zeros and ones.
So the final advice then, for you listening, the learner in this space, seems to be about integration and collaboration. Whether you're collaborating with human colleagues or using an AI co-pilot or even interacting with a remote robo for robotic surgery, the goal is always balance.
Balance is key.
Balancing your fundamental medical expertise, your human judgment, with the intelligent, careful deployment of these powerful technologies. So boiling it all down, what does this mean for your day-to-day practice? It seems your biggest responsibility now is maintaining that balance of power and ethical duty. You have these incredible tools, yes, but the obligation to ensure accuracy, to actively prevent bias, and to fiercely protect patient information. That responsibility is arguably higher than it's ever been.
Absolutely. And maybe here's a provocative thought to leave you with, something to really mull over. One of the speakers in the source material suggested something quite startling, that the current way we're using these tools, this current track, it might not even hold true for more than, say, 18 months.
18 months, that's incredibly fast.
It implies the pace of change is so rapid that it could require another massive disruption, maybe even a fundamental shift in career focus or how medicine integrates technology. So the question is, how does knowing the basics we talked about today, the GI Go principle, what supervised training really entails, the ethics of cloud data, how does that foundational knowledge prepare you for a future where potentially you might have to fundamentally unlearn and relearn your entire technological approach to medicine in less than 2 years? That preparedness, that adaptability, it really starts right here with understanding these core concepts.